Hi everybody, I'm Tony E at Show IP Interface Brief, and I saw a recent post on Twitter between Demetrius and the Land Tamer, and I saw their video and I wanted to be able to add some explanation. This was the GRE tunnel challenge, different tunnel interface IP ranges. I've actually run into this problem many times in production, so I have some experience in this, and I wanted to be able to share that. As I saw, it looks like the Land Tamer did not get EIGRP up across that GRE tunnel. Okay, so I quickly stood up a lab. I don't record many videos, so bear with me. A GNS3 lab. This is a representation of the INE topology. This is not the full INE topology. What I have here is router 7 on the left with the subnet that is part of the INE workbook, which is 155.137. And if I do a show IP interface brief here, I've given router 7 the .7 of that. I didn't put the loopbacks or anything else on it, as it's just going to simplify this explanation. And again, on the right side, I have router 8. And if I do a show IP interface brief here, I have the 155.158.8 representative of what it would be in the INE workbook. I'm not going to use any of the other subnets or anything, and I'm not going to try and recreate the topology here. This is just a quick and dirty explanation of how to get traffic passing over a GRE tunnel when the subnets configured on the tunnel interfaces is different on each side. Okay, so all I have here in this internet cloud is one router, which is the other side of each of these, and it's only the directed connected networks, no routing protocols in there. And I have only configured here a single default route pointing to the next hop, and that's just so I can reach all the way from router 8 to router 7. So if I do a ping 155.137.7, I should be able to hit it, and that should give us reachability from the other side. Okay, again from here, show IP route, I have only one static route, which points me to the .3, again representative of what the INE workbook topology is, and that sits here behind the internet cloud. Okay, I'm going to walk through and do a simple GRE tunnel configuration. I'm going to do it step by step, and maybe this will help to explain how some of these things work together. Okay, I'm going to start to configure tunnel 0. Again, I'm going to give it the same basic configs that Land Tamer was doing. So let's do tunnel mode GRE IP. Let's do our tunnel source. I'll give it our IP address, which is 137.7. And I'll give it the tunnel destination, which is the router 8's address. Okay, I'll come over here, do the same thing. I do believe the tunnel mode will default to GRE over IP. But just because it was in there, I was going to go ahead and do it as well. All right, our source is our IP address, and our destination is going to be 155.137.7. Okay, and just like the Land Tamer pointed out, the line protocol is going to come up. So if we do a do show IP interface brief, we can see that the tunnel is up, even though I don't have an IP address assigned to it. And that's because the tunnels, by default, they are virtual interfaces, and as long as there is a route to the destination, the tunnel interface will come up. That's what determines whether it's up or not. So if I take off the default route, it will go down, also because it can't reach it, but because it doesn't have the route. Okay? All right, so I don't remember the IP addresses you guys were using, so I'm just going to fudge it a little bit. Interface tunnel 0, I'm going to say IP address 155.1.77.1, and I'm going to give it a class C mask, a 24-bit mask. And over here, I'll increase the third octet by 1. 155.178.1. Okay. Okay, you see I have it configured. It's up. If I come over here, show IP interface brief, it's configured and it is up. Okay, so the GRE tunnel is up. I bet if we do a PCAP here, we should see those packets going across. Actually, we might not if we're not passing any traffic because we don't have any keep alives on. All right, well, I don't want to turn keep alives on just yet. I want to keep this simple. Let's come back to Wireshark after we get some traffic passing. So let me turn off this capture here. Okay, so now we want to go ahead and demonstrate that even though the tunnel is up, it's not actually passing traffic. So I cannot ping the other side of this, even if I source it from my tunnel interface. And that's because it doesn't actually have a route, right? It's actually going to try to use the default route. And when that packet gets sent across the wire, because if we do show IP route 155.1.77.1, subnet not in table, and because we have a default route, it is going to use the physical interface, and it's going to get sent over to what would be router 5 in the INE workbook topology. Once it gets there, if that doesn't actually have a route, it's going to drop the packet, and that's what's happening right now. Okay. So we can't actually configure any static routes because we don't have any next hops, right? The next hop, which is 155.1.77.1, the next hop from router 8, there isn't a next hop that's resolvable. So one thing we can try to do, we can try to configure a static route using the tunnel interface as an egress interface. So let's do IP route 155.1.77.0. I'm going to give it the .1 just to be more specific, so there can be no mistakes. And I'm going to say tunnel 0. I'll come over here and do the supplement to that, which is 155.1.78.1 32-bit mask, and use tunnel 0 as the egress interface. So now let's try again. Let's try to ping that again. And I can ping across it. Okay, so I can actually ping, and this should be going, it should be encapsulated in GRE now, and I should be able to obviously ping the other way. Okay, and just to be sure, let's capture that here. So we should see a GRE encapsulation, IP protocol 47. Let me bring up router 8 here. I'm just going to do a repeat of 1. Just give me one packet. Okay, I'm going to stop. And you see here's my source, 155.1.78.1, going to my destination, 155.1.77.1. Okay, and here's our GRE encapsulation, and we should be able to see that in our actual layer 3 header as, where's our protocol? Protocol 47. Okay, so it is actually being encapsulated in GRE going across the tunnel, and I'm getting the replies back. But wait, we're not done yet. I'm going to stop the capture just so I don't have it running in the background. Okay. Okay, so if this is reachable, and I can actually ping across the tunnel when they're in two separate subnets, can we get EIGRP running? Okay, so I'm going to turn on basic EIGRP, conft router EIGRP 100, and I'm going to put the network statement in just for our interface, right? The most specific. It doesn't actually have to be this way. I'm doing it like this because. Okay, I'm going to do the inverse here. Network 155.177.1. And I'm doing the quad zeros because it's a wild card, so I want it to be 32 bits. Okay, so we're getting this error, okay? Neighbor 155.1.77.1, which is router 7, is blocked because it's not on a common subnet. And that's because EIGRP actually uses multicast to send the hellos. But when it replies with a unicast. So it knows when it needs to reply with a unicast that it doesn't have, that EIGRP has a check to know that that subnet is not on a connected interface. Okay, so how do we get around this? Okay, so we have GRE reachability. I can ping across the tunnel. It is being encapsulated, but EIGRP will not form an adjacency. You see, it can see the neighbor. It's sending the hellos, which means the multicast is getting encapsulated in GRE. We can see that and prove that here. And it's not getting the acknowledgments. All right, here, let's see if we can get EIGRP hellos. Okay, here we go. Multicast. It's being sent from router 8 all the way across being encapsulated, and it's being sent from router 7 as well. The hellos are being sent, no acknowledgments, so they're actually not forming an adjacency. All right, and each of those is being encapsulated. Okay, so how do we get around that? Let me turn off the capture function. Okay. This is something that I've run into in production, which is why I was quick to speak up right away, and I want to be able to help the people who are my fellows, my friends online, who are also seeking CCIE, so we can help each other. EIGRP has a check, so it will not form an adjacency on a link that doesn't have a common subnet. So how do we get around that? The problem we have here is, let me do an end, come over here and do an end. Okay, I'm actually going to just take off EIGRP real quick, so I don't have any, oh excuse me, let me do no router. I'm just going to turn it off completely, and now you got me mixed up. We can just shut it down. Okay. So what we're going to need to do is we're going to need to utilize the IP unnumbered on the tunnel interface. And what IP unnumbered is it actually borrows the IP address of an active interface for its interface. So we are going to go ahead and take show run interface tunnel 0. We're going to go ahead and take this IP address and put it on a loopback. And instead of this, we're going to do IP unnumbered. So I'll show you what I mean. Since I have that on my clipboard, let's do interface loopback 0. I'm going to paste this in. This is the IP address of the tunnel. Oh, wait a second. It's not going to let me do that because it overlaps. All right, so first I'm going to go into my interface tunnel. I'm going to say new IP address. Okay, then I'm going to do interface loopback. I'm going to paste in the IP address we had for our tunnel. Okay. And then in our tunnel, I'm going to do IP unnumbered loopback 0, which means we want to go ahead and borrow the IP address from loopback 0. Okay, I'll show you what that looks like in the running config, show run interface tunnel 0. So again, everything remains the same source, same tunnel. Same source, same destination, but we're doing IP unnumbered loopback 0 and show run interface loopback 0, and there's our IP address. If I do a show IP interface brief, you'll see loopback 0 and tunnel 0 are both sharing the same IP address. You can do this any number of times. I can create multiple tunnel interfaces all borrowing the same IP address. All right, let's go ahead and do the same thing over here. Conf T interface tunnel 0, no IP address. Do show run interface tunnel 0. I want to grab the IP address first. I want to say new IP address, interface loopback 0, paste in the IP address, interface tunnel 0. I want to go IP unnumbered loopback 0. All right, show IP interface brief. And here you can see our loopback and tunnel are using the same interface. Okay. So I want to go ahead and check how we configure the static routes, because here we definitely need to use the exit interface instead of next hop for static routes. I believe we already have that configured. Show run pipe include IP route. Again, this is our default for our physical interface, so we can have connectivity from router 8 to router 7, and then here is our tunnel. Okay, so we're going to leave that in. I just want to double check, make sure we're still good over here. Same thing over here. Okay, so with this done, we should still have reachability. So I'm going to go 155.1.77.1, and I'm going to source it from tunnel 0. I'm going to source it from loopback 0. Loopback 0 is our actual interface, so we source it from there. It's the same IP address. Okay, and we know we can come back the other way. Okay, here's what's great about this. Show run section EIGRP. So we just have router EIGRP, and we have our network statement here, and that's all it was. Conf t router EIGRP 100 network 155.1.77. We're going to give it our specific interface. Okay, and here we have a full adjacency. All right, now I don't have any other interfaces on these routers, so we're not exchanging any other routes. But we can do show IP EIGRP neighbors. We can see we have a neighbor. It's up across the tunnel. All right, show IP EIGRP neighbors. Again, we have router 8. It's up across the tunnel. And just to show that we can have reachability and routing through the tunnel on discontiguous subnets, let's do interface loopback 123 IP address. Let's give it another octet. We can't have 3 octets. Okay. No shut. Router EIGRP 100 network. Okay. So go over here, check the routing table, and here's the loopback we just created, D indicating the Dijkstra's algorithm for EIGRP. All right, and just to make sure we have reachability, let's ping that sucker, source loopback 0. So now we have reachability all the way from loopback 0 to destination 123 across a tunnel, a GRE tunnel with discontiguous subnets. I hope this helped to explain a couple of things. So if we want to think about how does that work, right? If we have, I may do a terrible job of explaining this. Let's see. Okay, if we have our GRE tunnel here, typically you would have, let's say if this is a point-to-point, you're going to have, and it's a /30, you're going to have a .1 here and a .2 here. All right, so it actually knows based on its subnet that something is reachable this way. Because these guys share a subnet, so it has this route in the routing table. But when you have discontiguous subnets, it only has the network. In this case, we had the .77 here, and we had the 78 here. Each was a 24. In the routing table, it has no way of knowing how to get to 77.1 because it's not in the routing table. It wasn't until we put the static route with the exit interface, the egress interface of tunnel 0, which basically means you know the difference between a static route that has a next hop and a static route that uses an exit interface, an egress interface. The one with the next hop, it actually has to resolve the layer 2 information for the next hop. When you use an egress interface, it's expecting that the destination is on that subnet and that it can ARP for it. And similar can be said for the GRE. It expects that this prefix is going to be on the other side. So it goes ahead and encapsulates it and sends it over. And that's how we have the reachability across there. And again, that only works if it goes both ways. With the EIGRP, you can also run OSPF, anything else, and then you can have your BGP or anything else. I hope this was helpful. I hope it explains a little bit. I look forward to any comments or questions you might have. And thank you guys for watching. Thank you, Landtamer, for always putting out great videos. And I hope I can help. And take care, guys. Bye.